So one-dimensional prefix sums. Let's have an example right here. So this is our example array, and it's got 6 values, and let's say I wanted you to get all the sums of the numbers from this range right here. So I want you to get all of these. And what you would think to do here is to take, get those zeros back, to take the start and add them all together and get the answer. But the problem with this is that it takes too much time, takes too many operations. By finding this index, what you did was take this plus this plus this plus this. You did 4 operations, you did 4 additions. And that takes a very long time, and it's not very practical for very large arrays. Like, for example, if you're in a competitive programming or you're solving a problem with multiple thousands of ranges, each with like 1 million values in between, you're not going to add them all up. That's too many operations and it takes too long. So instead, what we can use is a strategy called prefix sum. And what this basically means is that we take our current array and we generate a new array that is 1 indexed. So it's going to have a 0 at the start, and then every single time, like to generate each of these next values, we're going to take our previous sum, or like our previous index, and add it with the current index of our original array. So we take the previous index 0 plus 5 equals 5. Now 5 is the previous, so 5 plus 7 equals 12. Now 12 is the previous. 12 plus 9 is equal to 21. 21 plus 2 is equal to 23. 23 plus 6 is equal to 29. And 29 plus 10 is equal to 39. So now we have an array where each number is equal to all the numbers in the original array before it added up. And what we really need to note is this array is 1 indexed. So this array right here is 1 indexed, meaning the content starts from index 1, while our original array, the content starts from index 0. So let me just label all the indexes here. So what you'll notice is that because it's 1 index, this array is 1 index, if you want to convert an index from the original to the new, you're going to take the original index, then add 1 to it. So 2 plus 1 equals 3, and they correspond. And now I want you to find the range of these numbers again. Well, you could add them up together. But using the prefix sums array, what you can do is you can say, okay, well, we're starting from the range 0 and we're ending at range 3. So let's convert that, starting at range 0 and ending at range 3 plus 1 equals 4. So we're ending right here. So we're taking these, and then we're going, okay, let's add them up together. It's 23. Because when we're making the prefix sums array, we've already added each of these values. So now we can just get the ending range directly, and it's 23, and we see the answer. And if we check our work, 12 plus 9 equals 21, plus 2 equals 23. We get the same answer by the prefix sums rate as we do adding them up manually, except this time we're only using 1 operation. We're just getting the value. Well, okay, you might say this works because the array it's this, like you're starting from 0, right? The array adds them up all from 0. We're starting from 0. Of course it's going to work. You can just get that one value. But what if we're starting from something like in the middle of the array? What if our range is not starting from 0, it's starting from 2 and ending at 4 instead? Then, first of all, we need to convert our range to 1 index range. So add 1, this is our new range. And so now we know in the prefix sums array, this is what we're trying to add up. But you can see it doesn't start from 0, so we can't really just get 29. Well, how do we get it then? Well, we're going to notice that this is basically, this range right here is basically the whole array minus these two. And now it's a lot easier because, okay, we just need to know the whole array minus where the starting range -1 is. And that's really easy. We can say, okay, well, we're starting from 3 and we're ending at 5, and 3 minus 1 equals 2. So we say, okay, ending at 5, we're going to subtract 3 minus 1 in x2. And now we can see 29 minus 12 is equal to 17. And if we add up manually, 9 plus 2 plus 6 is equal to 15, 17. Which took us only 2 operations. We only needed to get this value of the array and this value. Meanwhile, we would have had to add up all of these in the middle and potentially more if the range is larger. So that's the power of prefix sums. Now that we know how prefix sums work, let's go ahead and code it. So we're going to first have our main function here. And I'm going to do n is the number of numbers we're going to give it, and then we're going to create an array with that many numbers. So the size is going to be n, and we're going to read in all the values. And now that we have the original array, so let me just show you. If I debug, and I give you, so I'm giving it 6 numbers, the same numbers in the example, 7, 5, 7, 9, 2, 6, 10. I'm giving it these numbers, and bam, you can see it reads them in 5, 7, 9, 2, 6, 10. So now that we have these numbers, we now have to create prefix sums array. And okay, now we need to create a new vector array. And this array is going to have a size of n plus 1 because it is 1 indexed. Now we're going to create a for loop, and because it's 1 indexed, we need to edit the arguments of this for loop to start at index 1 because that's where the content starts at, and end at I is smaller than or equal to n. Once we have that, we can now create the array or dynamically add the values. So the current value of prefix sums of the current index is equal to the previous value plus the current array value. And that's it. That's all we need to do to generate our array. And so what this code is saying here is take the current array value, array index, and that value is going to be the previous, which remember the previous prefix sums value is adding all of the other numbers in the original array. So the previous is already the sum of all the other numbers in the array starting from 0 plus the current value of the array. And the current value is I-1 because we're dealing with a 1 index loop here into a 0 indexed array. But yeah, once we have this, let's just test and see that it added all the numbers correctly. So I'm going to create a dummy vector for debugging. Put in our array again, so 5, 7, 9, 2, 6, 10. And bam, you can see our array 5, 7, 9, 2, 6, 10, and our prefix sums, which has the 1 indexed 0 value, 5 plus 7 equals 12, 12 plus 9 equals 21, 21 plus 2 equals 23, and 23 plus 6 equals 29. So it made our thing correctly. Oh, and plus 10, 29 plus 10 equals 39. So I made our thing correctly. And now we need to give it some queries. So in A, B, read in the queries. And then, of course, these queries are going to be for a 0 indexed array. So we need to convert them to 1 index. So A++, B++. So now that these queries are 1 indexed, we can create a sum, which is going to be prefix sums of the second range. So B minus the prefix sums of the first range minus 1. And then we're going to print out our sum, and boom. So let's run this, give it our array, 5, 7, 9, 2, 6, 10, and then give it, let's say give it from the starting 0 index. So we want it 0 index to 0, 1, 2, 3. We want it to get all of these summed up. 0, 3. And bam, 5 plus 7 equals 12. 12 plus 9 equals 21. And then 21 plus 2 equals 23. Okay, well, it works fine from the 0 index starting range. Let's go ahead and see if we can sum the middle of the array. So let's start from 0, 1, 2, and end at 2, 3, 4. Bam. And 0, 1, 2, 9 plus 2 plus 6 equals 11 plus 6 equals 17. So that is how we make a prefix sums array.